Terrible?
Yeah.
Maybe for what's called...
Go on. Please,
Please.
please. I need to
Where
move.
can I move?
Go on, please. Math, isn't it?
Physics.
No, Physics. Hi, my name is Juan and I like physics.
Juan, when you sit down, if you want, you can slap him if you like. How old are you?
8.5.
Are you 18?
Yeah.
Yeah, now when you just take your bag off of Walmart, just let your hand accidentally spunk. That's it. Oh, no. Oh. Hit him. Him.
Who?
Him.
When? How? What? Why?
Who? That is no one.
How?
Yeah.
Why?
He was teasing you.
I wasn't speaking. It's
What's that?
very bad word in Arabic.
Yeah, well, not.
Oh, good, very good. Okay.
She was
It's no space there anymore.
Show some respect to
I have a
the
question.
elders.
I have a question. How will you write from the top?
Right in the voice.
Read from the top.
Read this off cat.
Wait.
Why don't you turn so it's easier for you?
Huh?
Turn so it's easy for you. You have to write it like this.
How?
Turn like this.
What's this next
Turn
rule?
more.
One and only one.
But it will make he can't see me.
I'll be fine, don't worry about me.
No.
As you wish.
She wants to sit facing you.
Look, this class is weird. And we have to respect each other's weirdness.
How early are you?
Roland.
Right.
Roland is probably stuck with it.
She would be the laptop.
Like talk to me, Roland.
Teach me to fight.
Now, dot product. You can write that down.
Oui.
Yes.
The thing that Wurzburg has a percentage error. Percentage error.
Yeah.
If they do that in physics.
Yeah.
Isn't the same as uncertainty?
Oh no. It's just the difference between the true value and your estimate as a percentage.
Values that
And I give that to you in the assignment, yeah. Come on. Dot product. Okay. By all Yahya. Be quiet. Okay. So far we know how to add, subtract, multiply and divide scalars. We know how to add, subtract vectors, and we know how to multiply a vector by a scalar. What we've not done yet is how to multiply a vector by a vector. We kind of saw how to do that in physics. How did we do it in physics? Multiply a vector by a vector. The cross product. So that's my group. And we have another way we can multiply called dot product, and it's not that difficult. If you have one vector, let's call it R1, and we'll say it's x1, y1, z1, and we have another vector called R2, and it's equal to x2, y2, z2, then you can say R1 dot R2 that's equal to x1, x2 plus y1, y2 plus z1, z2, which, by the way, is a scalar, not a vector. We have two ways to multiply vectors. We can use cross, which we learned in physics, or dot, which we're doing in maths.
Can we use this in physics?
There isn't any problems that we do in physics that would need dot. Yeah? That's right. There are things in physics that need dot, but not things we do. Yeah? Can I give an example? Simple example?
So we cancel out the direction from the magnitude?
Yeah, the direction is gone now. It's a scalar. So for example, if I had 212 dot 314, that would be 6 plus 1 plus 8. Yes? Which is 15?
Yes.
But notice that this is not a vector anymore. So why is dot product useful? We'll have a look
Cancel
now.
out vector.
Yeah, but why?
Yeah, why? No, I know it's useful to cancel out the vector, but like, no, why does the vector get cancelled? Not why is it important.
Why does the vector get cancelled?
Yeah.
What do you?
I mean, there are two vectors.
Yeah.
What if they're like, if they're in opposite directions and we multiply them, okay, I can get the cancel.
But the vector hasn't really cancelled. We've just found something when we multiplied the vectors together. We've not actually said what this dot represents.
Yes.
Yeah.
Yeah, like if we're adding the vectors, then this will finish, then this will start to have the
Yeah,
represented
yeah.
or something. But when we're multiplying, what are we doing? Like, let's imagine them as forces, what will happen?
Yeah, we don't have anything. There is things in physics that is represented by a dot, but not things that we do. The closest thing I can say is calculating the work done, because you know work is force by distance,
Yeah.
but really it's force by displacement, which are both vectors. But we didn't use the cross when we multiplied those.
Yeah.
We just multiplied the numbers. So then what do you do if they're at an angle? Well, this is where you can use the dot. But the way we dealt with angles in physics is by resolving it into the cos and to the sine. So the dot is useful in physics. Usually we see it in work calculations in 3 dimensions, something you'll do at university. Yeah. Okay, so let's see, what is the applications or the usage of dot? Here's give a quick example for you to try. Try this one, 4i plus 2j plus k dot
Are we drinking the same thing?
j minus k.
Y. W-I-N-E.
No, we got it. Your pronunciation was fine. Give me, let me see it.
No!
No, I won't take it, I just want to see it.
No, it's not. This?
It's soda.
Yeah. No? It's soda?
Yeah, it is.
Yeah, look at the
I don't-
color.
Yeah, it doesn't
I can smell the sugar and not the alcohol. It's definitely not wine. It's definitely soda. Okay.
You know, you know. It was a W-I-N-E.
Okay, can you try this example here, please? Hi, so can you try this example?
K.
Yes. Bye, so.
1?
I don't know how to check. Have you done it?
Yeah, I think. So, if there's no I, then it's 4 times 0.
Yeah.
So it's 1.
Yeah, so you have 421 times 0, 1 minus 1, which is 2 minus 1, which is 1. Very good, very good. Okay. I would like you to see what happens if you dot a vector with itself. So see what you get when you dot a vector with itself. Actually, we'll do this one together.
Square.
Yeah, what would be the first term?
X squared.
Yeah?
Y squared, Z squared. Plus.
Yeah. Now, where have you seen that before?
Circle.
But minus.
Yeah. It's like the magnitude, except what's missing? Yeah, so that's actually a useful result, that a vector dotted with itself gives us the magnitude squared.
And then we can square root it to that.
Yeah, exactly. So if we square root the dot product, we get the same thing as the magnitude. Okay, so write that one down. What is wrong?
This mark was there since the first lesson we came. And I took a picture of it with my camera.
Sorry, does this story have a point or?
No.
Is it the same place?
Same place.
How do you know it's the same mark? Maybe it's a different mark in the same
I have
spot.
a picture.
How do you know it's the same mark?
It is the same exact one.
How do you know? Exactly.
It's consistent. They're insects.
Well,
Like
what if the moth left and his friend came along and said, "Take over for me"?
Yes,
We're trying to freak Faisal out.
Sure. Not for example, it's not me, it's her. To fly and to bite you. This is toxic.
Yeah.
If you bite,
Ja.
If it's biting
Go on,
it's
go on.
You get
Don't
poison
listen
right
to
there.
them. It will not bite you.
It's
The
not
only thing.
kill you, it will just fall up.
It poops milk powder. Sen mosquito.
Go on.
Yeah, but a little bigger.
Go on. You should trust the person from Ireland.
It's worse than be. I got bitten by one of these last night because like 3 days ago.
Yeah.
And it left in the hospital.
This, just so you're wondering,
That's why I was
Fuan,
late.
Try, we're gonna do it.
The Bible says.
Fuan, if it bites you, you'll look like him. This is what happened to his face. Now, Fuan, it won't bite you. The only thing is,
If it bites you, become handsome.
Fuan, the only reason people don't like these is because if they're in your home and they get into your wardrobe, they eat holes in your clothes.
See?
See, it's gonna cut through clothes.
Yeah.
Can you imagine?
No, hold on.
Can you cut your clothes? No, you
Your
can't.
clothes won't protect you, even if it bites through your clothes.
Can,
It likes the eye especially.
can you please leave Fuan alone, okay, please?
Is it physics or physics?
Faisal, stop now, stop. Okay, we continue. You may forget what I'm about to say. Next. Have you got this written down?
Do you wanna try this?
No.
It's really bad.
Yes. That's why I don't get that flavor.
Yeah, but
You want to mix it with some black currant?
this is black currant.
It'll only enhance the flavor.
It's still cold, it's still hot.
Okay.
I'd say mix it and then just chug it.
Next example, please. Now, why is dot product useful? Well, I want to give you an example of why it's useful. So let me just give you two vectors. We'll call them vector x, for example. And we'll just say that vector is something like 5. We'll just do it in 2 dimensions to make it a bit easier. 5, 12, and just 5 and 12. We'll forget about the k for the moment. And then the y vector is minus 12 and 5, like that. Okay. Now, do you remember earlier I said? You should remember, I said, is it possible to write a vector as a sum of any 2 other vectors?
Yes, unless I don't remember this stuff.
Yeah, that was kind of the key. You can, yeah. So you can take any vector. So, Fuang, what's your favorite number?
9.
Okay, great. And your second favorite number?
4.
Okay, great. Is it possible to write this vector as so many of the first vector plus so many of the second vector. Is that possible? And the answer is yes, unless they're parallel. Is x and y parallel here? Are they parallel?
No.
No. For vectors to be parallel, they must be a multiple of one another. So for example, this vector, let's say it's 2, 4, that is parallel to this vector, which is 4, 8. Because the difference here is 2. Is that the case here? No. So it should be possible to do this. Okay, so to get started...
Question.
Yes?
If they're opposite to each other, do they still count as square?
Oh, if it's a minus?
Yeah.
Yes, it does. Okay, I'll give you some things to do first. So the first thing I want you to do is I want you to make x a unit vector. Remember how to do that? How do you make it a unit vector? What do you need to calculate? Magnitude, okay. Yeah, so what's x is a unit vector?
Wait, so R is the result of both?
No, it's not. Or is a random vector that Fuang picked, and we are going to write that as so many x's plus so many y's. Yeah, so what's the answer here? No. 5 over 13 and 12 over 13. Okay, B. I want you to unit vector of y.
No.
Well,
Minus
12 over 13 and 5 over 13.
Oh, okay.
Okay, C. I would like you to calculate x dot x. D. I'd like you to calculate y dot y.
Wait, how are you getting
You don't want the
13?
unit of R?
No, because or is the vector Fuang picked that we're going to rewrite as x's and y's. Or really, I'm going to rewrite it as so many unit x's and so many unit y's. E, x dot y, f, y dot x. G, I will show you something interesting. Okay, so, calculate please, x dot x.
Wait, so where do you get 13 from?
Oh man,
It's
you're
the
killing
R.
me here.
Right.
Busting my chops here. What do you mean where did I get the 13 from? You know where. The magnitude. Square root 5 squared plus 12 squared is 13.
X is 1.
Yeah, and y is 1.
So x squared is 1.
Yeah, but you knew that already because I just said 2 minutes ago, when you dot a vector with itself, it's the magnitude squared. And if it's a unit vector, what's 1 squared?
Whoa! Now this is mine.
Y dot y?
1.
1, okay. Now, x dot y.
1. Oh.
What?
1.
1.
What, x dot y?
Yeah.
It's not. Calculate it.
Oh.
Calculate it.
No, yes it is 1. Because x.
It's not the same.
Yes, I know it's not the same, but unit. Oh no, never mind. I fine. I'm not like you.
Stop talking.
Okay, I'm sick to this.
This is sick.
So what's the R used for?
I'll use it later.
Zero.
X dot y is 0.
How? It's moving in the opposite direction. And
No. Just 5. Yeah, just do it. 5 13ths times minus 12 13ths
Yeah,
plus
this is- yeah.
12 13ths times 5 13ths is 0.
Zero.
Yes.
Yeah, but is there a reason? Like, logically?
Yes, which we'll discover in a later lesson. There is a logical reason for why their dot product is 0. In fact, an important reason we'll see later. Yes. Now, what about y dot x? It'll be 0. Okay, so watch this now. Here's the g part.
Is it for all the G's?
I don't even know what that means.
Is it for all the gangsters? G.
I don't know. How many gangsters are in this room? Are we all gangsters? I don't know.
You're the main G.
I'm the big G and you're all the small G, is it? Yeah, yeah. This is you and this is me. Yeah? Alright. Actually, no, I'm so G, I'm G squared. Yeah,
I'm the power of G.
Yes.
Mental that.
Okay. This is the big G over all the small G's.
I'm G squared.
Right, that's enough gangster talk. Okay, so...
We only spit fire.
No, it's gone too far now. Or is so many x's plus so many y's. But with the result that we just have, it's actually very easy now to find mu and lambda. Watch this. If I multiply by dot x, I have or dot x equals mu x dot x plus lambda y dot x. But what's x dot x here?
1.
And what's y dot x?
0.
So what am I left with on the right here?
1.
Mu. So mu is equal to or dot x, which is equal to 94 dot 5 over 13, 12 over 13. And likewise, lambda will equal or dot y, which will be 94 dot minus 12 over 13, 5 over 13. Now, can you calculate those, please? Can you calculate those, please? Or I'll calculate them. 9 times 5 over 13 plus 4 times 12 over 13. So this one is 93 over 13.
Wait, could you just tell me why the y and the lambda cancel?
No, it's the y and the x cancel because we said y dot x is 0. 4 times 5 over 13. This is minus 83 over 13. So what you've just done is you've said or, which is 9i plus 4j, is the same as 93 over 13 x vectors minus 83 over 13 y vectors. In essence, what you've done is, instead of writing vector or using i's and j's, you've wrote them using these new vectors x and y's. If you put in what x and y is, so if you were to test it and do 93 over 13 times 5 13, 12 13 plus minus 83 over 13 minus 12 over 13, 5 over 13, if you multiply and then add together, you get back to 9 and 4. So what we've kind of done here is we've kind of changed the base. So in this picture here, you said or is 9 i's and 4 j's. But in this picture here, what you've said is or, we had an x here and a y here. We said it's so many x's and so many y's. So you've kind of change the base. You're using different vectors to represent or. No, I don't know if that makes sense. Is that confusing? I'm not sure. But I wanted to do an example that shows you why dot product is useful. It can be helpful for changing the vector bases that you use. That's just one application of it. Another application which Faisal saw earlier was telling if vectors are perpendicular. But that's something else we'll look at. I don't think I'm looking at that in this lesson. No. And for some reason there should be a plus here in that last one. Okay. Alright, did you write that down? You wrote that down?
By the base as an I and j to x and y.
No, you got minus 83 over 50.
I dotted orbit y. Is that not it? Oh, did you? What did you get? Sorry.
Minus
Minus 80.
8.
Minus 8 over 13.
Minus 88 over
88. Okay, so that should be, are you sure 88?
not sure.
Yes, minus 88. He is correct. Sorry, that's an 88, not an 83. He's right, just chug it down, it'll be over sooner. Do you want me to hold you back and pour it down your mouth? No thanks. Okay, you wrote this down? Yeah. Continue? Yep, okay. Can you try? Question 2 now. It's another true-false question like yesterday. Oh, we're losing Andrew. He's phasing out. We're losing him. Come back to us, Andrew. Or do you need to take a 5-minute break now before you try these?
No.
Are you sure?
Yeah, I'm sure. Just thinking about something.
Oh, do it. Come on.
It's always like.
We're doing 2?
Yes, we are. Yes.
Yeah, I have everything else written down though, so.
I wanted to ask a question.
What?
If we're multiplying vectors,
Yes.
you said the resultant would be in a different plane.
For cross.
Yeah, as in x times y or I times j equals k.
Yeah.
Okay, does it make a difference if k is, let's say, going up or down or going in or out? As in, how would we know if
Move the cursor.
Oh, yeah.
As in, you said that I and j are like this and then k is going up.
Yeah, it does. The convention is that k going up. It's a different system to have the k going down.
Yeah,
Yeah.
so how would we differentiate between this?
You don't. The standard system used here is how I drew it.
Going up.
Going up, yeah.
So if it's going down, then it's a negative?
Yeah.
And it has to be perpendicular?
What has to?
Has
The
to
two
be-
vectors?
No, the third one.
Oh yes, has to be perpendicular to the other two.
Okay, if it's like, if it's not going up, but if it's going this way, it's still perpendicular.
What is?
I mean, I and j,
Yeah.
k.
Yeah.
It's going this
That's not
way.
perpendicular anymore.
The plane it's in is perpendicular.
It's not. The plane makes an angle with the ij. Try number 2, Faisal.
Can you zoom in? Or adjust the focus?
No?
Yeah.
Do it. The teacher can see you're not working. Do some questions. Have you done anything for number 2? Want to start it? Good call, good call.
have to write whether it's true or false.
After you check it, yeah.
Do we have to check it at the top?
Yes! Yes! Yes!
In cross multiplication, A times B, let's say, is not the same as B times A.
Correct.
And one of the rules of vectors AB equals vector B minus vector A.
That is a rule, that's a fact, yep.
Okay.
How can you check something like B? Like you multiply A by A.
Yeah, and then on the right you get the magnitude of A and square it.
But you know that this is true.
Yes, but I wanted to check with numbers because, as we've established yesterday, people don't believe me because they think I'm a dirty, filthy liar and they need proof.
Big fat
Now hang on, don't bring weight into it. I said a dirty, filthy liar. I did say a big fat liar. What?
There's a movie called Big Fat Liar. Called The Hint.
Never heard of it.
Probably when you were our age.
Never heard of it.
No, really.
Who's the actor?
Frank Muniz.
Ew.
Not sure.
I don't know this dude. You're finished, Warren? Okay.
It's a really famous movie. In 2002.
Show me, quick. Never. No.
Steven Fidget did this from back home.
Yeah, Faisal, get out of the way.
Oh.
No, I don't know this movie.
But do you recognize this?
Nope.
You don't know this movie? Anyone have heard of this movie?
I've heard of something similar.
Maybe.
2002, it's old.
Oh yeah, I think I've seen it, yeah.
These folks.
Not that good though.
No, it's a bad movie.
Okay.
5.4 IMDb ranking. Score.
Which one are you on, Warren?
D.
Yeah?
These folks, yeah?
Did you check with numbers?
No, because I can't.
Why
I
not?
can only do it like I can only think about it because B plus C is CB.
No, it's not.
No?
B plus C is B plus C.
No,
Which?
the rule we took.
No, there's no room for B plus C.
Okay,
course
but
not.
we can't move.
What's wrong with you, man? B plus C will be 3 minus 2, 0. When you add B plus C.
Which is that? The I and the J and the K? What?
Yes.
Okay. This is gonna be false anyway.
Why don't you see?
Yeah.
Okay, are we ready here? Not yet? Okay. Andrew, you did the 4 of them?
Yeah.
Yeah.
Can you do these?
No. Because it's easy. You're just being lazy.
I did the first 3.
Yeah, because you're lazy, so do D.
What's do it?
Well, there's the door. Don't let it hit you on the way out. Alternatively, if you don't like that suggestion, there's the window. Don't let it hit you on the way out. You did all 4? Did you?
I technically did, yeah.
Did you technically? Did you technically?
True, false, true.
We'll see. Andrew, you're finished then. Okay, part A. True or false?
True.
B.
True.
C.
False. True. False. I wrote false, but it's true.
No, three false.
False.
Which is it, true or false? It's true. It's true. It's true.
False.
False.
True.
Hang on, let's do this.
Of course
Look,
it's true.
what's B plus C? What's B plus C?
Yeah, true minus.
What's B plus C?
True.
3 minus 2, 0. And then what's A? 1 minus 1 minus 9. Yeah? Correct? And when I dot these, I get 3 plus 2, which is 5. Now let's look at the right. A dot B, A dot C. So if I dot A and B, what do I get? 2 plus 3 plus 27, I think. Isn't it? 9 times... Oh no, sorry. 80 plus 81. Thank you. Is that right?
Yeah.
And then here A dot C, that'd be 1 minus 1 plus 81. Like this, yeah? And between them is a plus. Oh, I've done something wrong here. No, because it's... No, I did something wrong. Please, believe me. I'm sure.
Minus 9 plus 9. Minus 81.
That's minus 81. Okay, so that cancels that cancels that. 2 plus 3 is 5, so it's true. Okay. Now,
True.
is it really true or is it false?
False.
False. False.
What are we thinking?
I say
False. False.
False.
Okay, let's have a look here. So what is it? AB dot Faisal.
BC.
That is B minus A dot C minus B. This is just using the triangle rule. But from using the rule you just saw was true, this is the same as B dot C minus B minus A dot C minus B, which is B dot C minus B dot B minus A dot C plus A dot B. And what do we have? We have B dot C minus B dot B minus A dot C
minus
plus A dot B. So it is true. It's true. And you can check it by putting in numbers again.
Put the number in.
Okay, they're all true.
Then you made a mistake. Yes, then they're all true. No,
How do you get that?
because I'm a jerk like that. Guys, you just have to put the numbers in and check. But I can't see. And what did you get?
Yeah, try.
False.
It's not, guys. It's not. It's true. How did you find AB? Did you do B minus A?
No.
Then you did it wrong, because what did you use for AB? On the left. You used A minus B. Smooth. That's wrong. It's B minus A. And what did you use for BC?
C minus B.
B minus B.
C minus B.
C minus B is correct.
Yeah.
Yeah. What was your BC? Tell me what you got for BC.
Minus 1.
Yeah.
Minus 4.
Oh.
That is
Wrong at the start, huh?
Yeah. It's still wrong. Oh, yeah, it's still wrong.
No, it's not.
Even
What you mean to say is you're still wrong.
no, because the other sign.
No, you're wrong.
But when it's
You're
still
wrong.
wrong.
No, you're all terribly wrong. Yeah, it's true. Yeah.
Yeah, it's true. I believe in.
I do.
Do you believe me? Don't be a Faisal on me, please. Do you need me to do it?
Yeah.
Oh, okay. Right, let's do this. Okay, what's AB here?
Wait, so what did you do it without putting in numbers?
No, we'll do it with the numbers. AB is B minus A. What's B
Yeah.
minus A? What's B minus A? 1,
Minus 2
minus 3, minus 2, and then minus 9, yeah, 0. Okay, and what's BC?
minus 1 for 18.
Are you sure?
Yeah.
1, minus 1, 4, 18.
Yeah.
Okay, and then what happens when you dot them?
Then minus 1, minus 8, and 0.
Minus 1, minus 8 and is minus 9. Okay, let's see what we get here. B dot C. Yahya Faisal. Work or get out. Put the phone away. No, I'm not convinced. I want to put into your purse, please. Sorry, your handbag.
What?
Sorry, pencil case, whatever. Alright, B dot C. What's B dot C? No, B dot C.
The answer on
The answer of B dot C.
2 minus 3 minus 18.
Minus 18, you say?
81.
There we go. 2 minus 3 minus 81. 2 minus 3 minus 81. Yeah? What is it? Minus 82. Okay. Next is B dot B.
4, 9, 18, and 81.
4
9.
plus 9.
Oh, yeah.
Yeah?
And 81.
Okay. And that is 94, is it? No.
No.
Yes. Next, A dot C. What's A dot C here?
1 minus 1 minus 81.
So that's minus 81. And then lastly,
2,
yep,
3, and 81.
like this. Okay, and we want to do this one minus this plus this minus this, isn't it? No. This minus this minus this plus this. So the total is minus 82 minus 94 plus 81
Yeah.
plus 86. Yes? Yes? So, what do we got here? Let's see. Minus 82 minus 94 plus 81 plus 86. I got, dun dun dun, the same. So it's
You solve this one.
yeah.
wrong in the last part.
You're
Yep.
always wrong.
Yeah, well, at least he tries.
I tried to.
Yeah.
But in life, people will wrong, not always right.
Reach a
Yeah, but I'm always wrong.
Well said.
Now, we'll take a break for 5 minutes and then we'll start the next lesson. Well, you'll have the time it takes me to go make coffee and come back and not collapse. It's too hot in here. Trying to move. No. I saw Wonder Woman yesterday and I thought it was good.
Yeah.
You said this yesterday.
No,
No,
I couldn't
this
have.
morning.
This morning?
That was today.
Yeah?
Smallville. Classic. It's like 10 seasons or something, wasn't it?
Yeah.
Did we 10 seasons for him to fly? Spoiler alert.
No, I watched it.
I know.
Like 4 times or something.
I know. I think because that show was successful is why they did.
The Arrowverse.
Yeah. Because I think that kind of proved that such a thing could be successful. I like Arrow, and I like The Flash. I just think Legend is stupid. Yeah, they're a bunch of nobody losers with a nobody story.